Hello and welcome to this course. We'll take a look at Zensol's CBA32P measuring instrument produced by Zensol Automation in collaboration with Hydro-Quebec. At the end of this module, the participant will be able to use the CBA32P Circuit Breaker Performance Analyzer. Lesson 3, Test Plan Loading and Cable Connection with CbaWin. Load a test plan with CbaWin. Load a test from the Zensol Universal Test Plan library with CbaWin. Load a test with optical encoder. Make the connections using CbaWin. Connect the cables to a GVH. Connect the cables to an HPL 330B2. Load a test plan with CbaWin. An existing test plan must first be loaded. If you've clicked on the wrong choice, you can always return to this window by clicking on the magic wand icon, the first toolbar button. You can also open a test plan by clicking on the second Open Plan button. Load a test from the Zensol Universal Test Plan library with CbaWin. From the directory where CbaWin is installed, go to Zensol Universal Plan, then choose the appropriate plan. How do I load a test plan with an optical encoder? If contact displacement tests are to be carried out, we need to know whether digital, optical, or analog resistive encoder sensors are to be used. As mentioned earlier, electricians are increasingly using optical sensors, as they are more accurate and easier to use. Once the type of sensor to be used is known, it's time to choose the right test plan. This is a file ending in WCF. WCF for test plan configuration. Make the connections using CbaWin. Once the WCF test plan has been selected, the front panel of the CBA32P is displayed, along with the connections to be made to the circuit breakers. Check that the connections of the contact cables, with their yellow and red clamps, as well as the inputs used for the sensors, match what is shown in the picture. This ensures that test results are visualized on the graph. In this example, we can see that 3 contact cables need to be connected to the first 3 contact inputs. Connect only the yellow clamps to activate only signals 17, 19, and 21. Only the first 3 optical encoders are activated, signals 89, 90, and 91. The optical encoders must therefore be connected to these inputs. At the bottom, read the important notes. At bottom left, the blue arrows darken and are used to view the configuration of subsequent tests. It's important to look at the tests you're going to run to check that they correspond to the circuit breaker's specifications. In the right-hand section, enter information about the circuit breaker, the high-voltage substation, the serial number, the location, and any other useful information. Click on the relodge to update the time and date. The small arrows lead to squares 10 and above. Once you've checked everything, click OK. You can always return to this page during your tests if you forget to enter any information. To do this, click on the 6th blue Connect and Info button. The information you insert will appear in your tabular and Excel reports after export. Connect the cables to a GVH. First, connect the grounding cable. Note that this cable will be the last to be removed at the very end of the tests. Then connect the power cable to the front panel of the CBA32P. Connect the fiber optic communication module to the computer. Pay attention to TXRX indications. T for transmission, R for reception. You'll find the explanation in Zensol's manual, the quick installation guide. The control cable is connected to the coil or relay, depending on the circuit breaker. This type of circuit breaker has 2 inseparable contacts per side, located inside the circuit breaker. There are 2 connection methods. Either use 1 cable per contact, in which case you'll need 3 separate contact cables, or use just 2 contact wires, as we'll see below. If the test plan you're using calls for 2 contact cables, as shown here, here's what you need to do. For contacts, take a contact cable and connect it to the first contact input. Connect the yellow clamp to the A side contact. the red clamp to the B side contact, and the black clamp to the common of one of these two sides. Then add a jumper that connects the two sides A and B. Take the second cable connected to the second contact input. Connect the yellow clamp to the C side contact, the black clamp to the C side common, and do not use the red clamp. In this way, side A is on signal 17, side B on signal 18, and side C on signal 19, as required by the test plan. Connect the cables to an HPL 330B2. Connect the cables to an HPL 330B2. The connections between the computer and the CbaWin are identical to the previous slide. As far as contact cables are concerned, here's an example of an HPL 330B2 circuit breaker, with 2 contacts per phase and an insertion resistor. The contact cables have one of 3 battery clamps, 1 yellow and 1 red for 2 dry contacts, and 1 black for common. In this case, a single cable per phase is sufficient. When the Zensol universal test plan is opened, the software window shows the active inputs to which the cables are to be connected. Just follow the connections. Here, the first contact input is connected to phase A, the second to phase B, and the third to phase C. For each phase, the yellow clamp is on contact 1, the red clamp on contact 2, and the black clamp on common. The second entry is on side B, and the third entry on side C. For each phase, the yellow clamp is on contact 1, the red clamp on contact 2, and the black clamp on common. Question Lesson 3. What is the extension of a test plan file? A. WCF. B. BUDT. C. GCF. D. GCF. The answer is A. WCF.